Hi, my name is Alexander Lai, and today I'll be talking about my deep learning final project where I built a digit detector, as you can see below. So this project stemmed from a curiosity I had with object recognition, and I think it's a very interesting topic because it's quite ubiquitous in our society. A lot of apps use images and have some form of object recognition in it. So I thought it would be a really interesting idea to further learn how these object recognition algorithms work and possibly even build one to perform this task. So through my initial Google search, I found this data set known as the Street View House Number Dataset from Stanford, or the SVHN. And it displays images of digits, as you can see below, and I thought it would be a really good idea to build a pipeline or algorithm to detect these digits by drawing a bounding box around them and then classifying them based on what they are. And I thought this would really be a good starting point in actually learning how the object recognition software works. So that's what I did for this project. So the pipeline or algorithm that I developed kind of has 4 stages. It first processes the SVHN dataset and feeds it into the convolutional neural network that I train. And then once it's trained, I apply like a sliding window across an image and take segments of an image, feed them into the trained CNN, and have it output whether or not it's a digit or not. And if it is a digit, it will save the coordinates, draw a bounding box, and with all these bounding boxes, I perform non-maximum suppression to only draw the most optimal boxes in the end. So this is the whole entire sequence of events. And throughout, when developing this algorithm, there are like numerous points that I had issues with. Um, the main one was pretty much trying to figure out the most optimal parameters that would give me the best detection results. For the image processing, I had to experiment with different types of processing, such as normalization, which I ended up using, grayscaling, or even mean centering. The convolutional network was a lot of work to train because it takes around 40 minutes to train one model. And because I really wanted to experiment with different parameters, the time really added up to trying to figure out which parameters would give me the best model. Also, the sliding window algorithm, it took a while to figure out parameters such as the sliding window ratio, or the different scaling factors, as well as how to feed the images from the sliding window into this trained CNN. So all of this took a while to figure out, but I think in the end, the final algorithm and final parameters I developed does a really good job actually um, classifying and localizing digits. So here's where you can see the results of my digit detector algorithm that I developed. The top 3 images show good results, meaning that the detector was able to draw a bounding box at the appropriate location and accurately classify digits. But of course, the detector also has some issues as well. And you can see those on the bottom where you can see examples of bounding boxes that are not the correct size, misclassified digits, and false positives that says there are digits when it's actually not actually a digit. So moving forward, if I want to improve and work with this algorithm more, I would do 2 things. First, I would want to improve the training process by adding more non-digit images to the training set. I already add some, but I feel like it's not enough. And also trying to skew the training images as I feed it into the CNN, meaning possibly blur it or transforming it by rotating it or something like that. Second, I would want to move away from the moving window algorithm because it's very slow. It takes around 30 seconds to scan through an image, so I would want it to move to more modern techniques such as using RCNNs and anchor boxes to do faster localization. In this way, I would be able to work with real-time localization and video feeds, which I think would be a very interesting project. But overall, I think this is a really good starting point in my understanding of how object recognition works. And I'm very pleased with the results. It did a lot better than I expected. And I look forward to seeing what I can do with this knowledge in the future.